Hi, I'm Danielle Boyce. I'm the Director of Data Science and Biomedical Informatics at the ALS Therapy Development Institute, and I'm also on faculty at Johns Hopkins University. My passion is teaching researchers about the OMOP Common Data Model and the OHDSI community. And this is a gentle on-ramp to OMOP and OHDSI. So the way I teach this is I like to give you the most confusing parts first and just confront them head on. Because what I found in teaching folks for about 5 years, hundreds of people, many different institutions, and different roles at their institution, is that they tend to read ahead and without having the fundamentals, and they read certain things and they get really intimidated, which is why I have that little pink storm cloud because they're all excited and then the cloud rolls in when they start reading and they have imposter syndrome. So what I have developed is this formula for teaching. I want it to be 20 minutes. We'll try to keep it within 30, no more than 30 in this video. Um, and this formula that I've developed is a way of learning it to take all of the intimidating parts aside, focus on what really matters, and then by the time you learn about the things that I'm teaching you, you will feel so confident that you can tackle all the intimidating topics. So I hope you enjoy it. First and foremost, you belong here. I need to say that out loud because I think you probably need to hear it. So you've probably led trials and wrangled large data sets, or you're the person that people come to with their data questions. Maybe you're thought of as the data person in your department. But so what if you've never installed a Python library, right? Maybe you see GitHub and OHDSI, OMOP, and you think, oh my gosh, I've never done GitHub before, or oh, maybe I'm in over my head. No, you belong here. You are not behind. You are an expert with a different set of tools, and we just add a few new ones. And that is very important for you to understand. I cannot stress that enough. A lot of my colleagues who work with me in OHDSI and are great leaders do not do any coding, no programming, or anything like that, and they're extremely valuable. So OHDSI is really a team sport, and we mean that. We mean that. And so you might pick up skills that you didn't think you'd even like to work in, and you love it. You find that you really love it. But even if you don't, that's okay, because there's something for everyone in the OHDSI community. And one thing that confuses people, which I can understand why, and I remember having the same confusion, is the difference between OMOP and OHDSI. So what do these acronyms mean? So go to the book of OHDSI, and in the early chapter, it talks all about this journey and how OHDSI and OMOP came to be. But the shorthand is OMOP is the Observational Medical Outcomes Partnership, and that's what we refer to really as the Common Data Model. So when we're talking about the tables and how they fit together and the actual, we call it CDM, the OMOP CDM, it's usually in reference to the actual specification in those tables in that database, and the vocabularies within that database. OHDSI, the Observational Health Data Sciences and Informatics, is what we use to describe the community. So if we're talking about a symposium or annual symposium, or the OHDSI community call, or do we know anyone in the OHDSI community who has X skill? That's what we're referring to. So you wouldn't necessarily say someone in the OMOP community. You'd say someone in the OHDSI community. But likewise, you wouldn't say the OHDSI Common Data Model. You'd say the OMOP Common Data Model. So that's just the shorthand, an easy way to remember it. I was really intimidated too. So I've been 30 years in this field, data science analytics, about 20 years working with EHR. So you'd think I'd be an expert already in OMOP, because a lot of the OMOP data that you might work with originates in electronic health records, but not so fast. I was very intimidated, very much so. And I started working with OMOP about 5 years ago and taught myself, and then came to Dr. Naji at Hopkins and said, I'm really curious about this. I think this could really unlock a lot of the answers in rare diseases, which is something that I'm focused on, and really interested in how we could leverage electronic health records and observational research at scale, and very interested in reproducible research. And that's how I got into this. And he was very warm and accommodating and just kind of threw me in, and I learned and I figured it out. And so the things that terrified me, which at that time were ETL, extract, transform, and load, I just thought that sounded so confusing. And that is my specialty now. I'm very good at that now. And I'm actually a sought after leader in the community on the very thing that scared me to death. So there you go. So and I know a lot of people who are in this same exact situation that have very similar stories to me in the Odyssey community. In the next 15 minutes, I'm going to tell you 3 things that you should be focusing on early in your journey, but also 3 things that I don't want you to focus on. And I do this because I have found over the years that the things that make people feel very intimidated, stressed out, imposter syndrome, are the things that represent a lot of applied knowledge. You have to have a lot of fundamentals down before you do them, but nobody really tells you that. So you come across these topics and you think, oh, I should be picking this up right now. And you don't understand that that's something that you really should not be learning until you've mastered these other things. Or some of the things you don't even have to ever do or worry about, and you can still make a huge contribution to the community. But if you read about them and nobody has told you directly that this is not necessarily something you need to worry about right now, if nobody's told you that, they might think this is something they need to do, and it might turn them off and make them not want to proceed. So bear with me, trust the process. Extract, transform, and load, ETL, Hades, and network studies are the 3 things that students find very intimidating to read about before they have the fundamentals down, and they make the mistake of thinking that because those things sound confusing and intimidating because they don't have the fundamentals down, that Odyssey is not for them. And so I like to lead with these things and explain to you why you either don't have to worry about them at all, or you don't have to worry about them yet. So ETL, extract, transform, and load. That's how you get the data from the source, so your raw EHR data, for example, into the OMOP CDM. And so this is a complex process. It's really fun. I've done it several times before. Most academic institutions, most hospitals have a team that does this. Like at Johns Hopkins, we have people who do that, and the researchers do not have to be involved with that at all unless they are making suggestions about things they want to add to the ETL or things like that. But typically somebody else with expertise in that does it. But even if you are in charge of doing it, like I am at ALS Therapy Development Institute, I could never have done it without the fundamentals. So what I'm suggesting to you is if you come across the materials for ETL, which are often kind of bundled in with all kinds of other materials about other things like vocabularies and common data model that are fundamental that I'm going to tell you to focus on, and you see ETL right alongside of it, it's very hard for you to pick out what should you be focusing on now versus versus later when you have the fundamentals down. So that's why I'm telling you, if you come across ETL stuff and it's intimidating, wait until you have a better grasp of the fundamentals and then come back to it. Likewise, Hades, incredible, incredible advanced analytics tools, absolutely incredible, but very intimidating to new students in my experience. And so again, if you happen across Hades materials, I'm not discouraging you from looking into it. It's great. It's so cool. It's so interesting. It's just remarkable and inspirational, right? But if you don't have the fundamentals down, you're not going to be a great user of Hades anyway, because you're not going to really know how to leverage the tools to their best advantage. And so if that intimidates you, don't worry about it. It should be intimidating. Wait, learn the fundamentals a little better, and then come back to it. Likewise, network studies. Now, this might be confusing to you because you might be in my class when the goal at the end of the fellowship or the class is to participate and help to run a network study. But what I mean by this is if you start by reading all the chapters about network studies and you don't have the fundamentals down, if you start by watching videos and looking up network study protocols and you don't really truly understand how everything works, the very fundamentals, then it's going to be way more confusing than it needs to be. So if you come across that and it's intimidating, let that be a sign that you need to do a little bit more work on the fundamentals and then come back to it. These are all some of the coolest things that I do, and I love working in all 3 of these areas. And in fact, I have a lot of expertise in all 3 of these areas. But none of us do these things alone, even if we do have a good grasp on them. Okay, at Johns Hopkins, we have folks who help with Hades. I'm one of them, right? And with network studies and with ETL, we have big teams that help us do that. And even if you don't have a big team at your institution, like at ALS Therapy Development Institute, there's just a few of us, I can reach out to the Odyssey community and they will help me out. So I just want to name these because I do find these things to be the things that people read that makes them think this isn't for them. So don't worry about it for now. Just 3 things I want you to learn, where I want you to focus right now. Number 1, the common data model. This is everything. Learn this. Learn this first. Common data model linked here. I did not learn about this link until I was about, I don't know, 18 months into my Odyssey journey, and it was a game changer. So I lead with this. Learn this common data model inside and out. What you're looking at here is 5.4. If you go to this website and scroll down, this is the image you will see. And then if you go up onto the navigation bar, go to the CDM 5.4 documentation. It's every single table with all of the requirements, all of the conventions, everything about every table in the CDM 5.4. And I say 5.4 because that's the version that a lot of hospitals are on right now. And so it's probably going to be most, and by right now I mean July 2026 is when I'm recording this. And so you're most likely to be relating to that in any work that you might be doing with a real CDM. So I want you to go through and look at every single table. So the tables are in white here, these little boxes in white. And note that the person table, that's where your data about the people in your data set are. It's a patient-centered or person-centered CDM. And so here you will find things like gender and race and ethnicity, date of birth, okay? And then going all the way down, visits and conditions, drugs, and so on. And so that's what gets populated in there. So study this, learn what is required of each table, what are the conventions, what are populated, and just roll around in it. Doesn't require any coding. You don't need to know R. All you need to know is how to get to this website and mess around in there. And so that's why I really want you to focus on this, because everything that you do is going to come from these tables. So you need to know what's in there. You need to know how it's organized. And the better you are at that, the better everything will be for you. I also want to draw your attention to the middle here in the orange, standardized vocabularies. Something that really confuses people about the CDM, because it's just not something they've ever had to do before. We do not have a PDF of a data dictionary in OMOP. We have the standardized vocabularies and this CDM, the schema. That's what we have. So the vocabularies, which would be, for example, the ICD code for gestational diabetes, what is the standard OMOP concept for that, the linkage to that. Those are in these tables. The information like that is in these tables, which are embedded into your CDM. So you can query, not just give me everybody with the concept ID representing gestational diabetes, but you can also, as I'll show you in a future slide, you can also query everything below it. So give me everyone with gestational diabetes and everything that could be considered gestational diabetes in this hierarchical vocabulary system. And so it's very valuable for you to understand that these vocabulary tables are actually inside this database, which lives at your institution under lock and key somewhere, and that you can query your data along with referencing these vocabularies all in one step. And this is something that the software tools are also built upon, and that is why you're able to leverage these powerful hierarchical vocabularies, which I'll cover in just a second. So the common data model, another part that I really want you to understand that tends to confuse people is just because something is related to a condition doesn't mean it's in the condition occurrence table. You have to break up what your fact is into the appropriate place and to understand where it is housed. So for example, the coded diagnosis, ICD, of gestational diabetes, that would be in condition occurrence. But a questionnaire about gestational diabetes, like how has diabetes affected your quality of life, that would be an observation table. And then it's linked by unique identifiers. these IDs. It's a relational database. So if you don't know what a relational database is, no shame, but you need to get a sense of it in order to understand how these tables relate to one another. Because that's a piece that really confuses people, is the relational database and the fact that we organize our facts about a person based on the type of fact, and then we link people and visits by these unique identifiers. So here's the vocabulary, more on this. So let's say you have 2 hospitals and a patient advocacy group's registry. Hospital A might record gestational diabetes as its ICD code. Hospital B might have it in a note, patient has gestational diabetes, and a PAG registry might have diabetes and pregnancy question mark and yes or no. Through OMOP ETL process, using these standardized vocabularies, all of those different disparate ways of representing gestational diabetes gets turned into one OMOP concept ID. That OMOP concept ID for gestational diabetes, which you can find in Athena. So I strongly encourage you to go to this website and learn all about standardized vocabularies and play around with it. But that concept ID that all of the different hospitals turned it into, that concept ID, now that is organized into a hierarchy. So you might know if you're a clinician or somebody like me, fun fact, I had gestational diabetes 4 times, so I know that on my chart it can be coded all kinds of ways. You can have A1, you can have A2, you can have it complicating pregnancy and childbirth. And so all of these different ways that different ICD codes and subcodes that it might be categorized in these different source databases. So once you know in the hierarchy where things fall, then instead of having to look up every single ICD code that falls under gestational diabetes so you don't accidentally miss someone who had the class A1 coded but not that main gestational diabetes code. You don't have to worry about that because your vocabulary tables are embedded into your CDM, that instance, those orange group of tables that I showed you about earlier. Because they're all embedded together, all you have to do is ask for that parent and all descendants when you're writing a query, and it will give you all of these class A1, class A2, and so on, all at the same time. So that's very important that you understand that and not gloss over it. Really get how that works, understand how that works in very practical terms, and spend as much time as you need to really understand that and play around with it. And so again, this is how it looks in Athena. If you go to the hierarchy tab, it'll even show you, here's your gestational diabetes. This is what it looks like in Athena, the standard concept for that. And here in the middle is the gestational diabetes. And then these little arrows show what's above it and what's below it. That's how you understand what the hierarchy is. So you can say, give me gestational diabetes and everything under it, all the descendants, and then you will get a nice clean catch of everyone who has anything related to gestational diabetes. Or you can say just exclude certain items, and it can do that too. And the third thing I really need you to understand and feel in your bones is this notion of federated research, where you might write a script, and then that script goes out to different sites, but you don't have to share your data with those other sites. And that is so important for you to understand on so many levels. For one thing, it's really important for you to understand as you're making a justification to your institution as to the value of this. The value of this is you don't have to actually share your raw data. And that makes things a lot easier for data use agreements, IRBs, institutional review boards, and so on. And so that's how a network study works, is somebody proposes the study, writes a protocol, makes a study package, and then the individual sites run those study packages. You don't have to understand exactly how network studies work, but you need to understand that this is the fundamental mindset around how OHDSI studies operate. And this is very important because I think when we gloss this over, then the concept of network studies makes no sense. If you don't understand the idea is to be able to run the same script across many institutions, pull the results of those scripts, but not the raw data back together, and then generate evidence from that using sophisticated methodological tools developed in part by the OHDSI community. If you don't really have a good understanding of that, then none of the rest of this is going to make sense. So I'm going to stop there. If you want to stop and just take that in for the 20 minutes, then you can stop there. But I'm going to keep going and talk about what makes a good research question next. And that might take us to about the 30-minute mark. So what makes a good research question? Almost every OMOP or OHDSI study is one of three kinds of questions. Clinical characterization. So what are these people like and what happens to them? So who has gestational diabetes and what is their care? So then you have population effect estimation. Sorry. Does this treatment change this outcome? So does drug A versus B change preterm birth risk? And then you have patient level prediction. For this person, what is likely to happen next? Will this person progress to type 2 diabetes after they've had gestational diabetes? Okay. And so you really need to be able to match your question to a bucket. And if you are able to do that, then you have a really good use case. This is something that confuses people a lot because they're just used to being able to do analytics on data sets that were collected for the purpose of analytics. So like a clinical trial was set up so that it could be analyzed for the purpose that was stated at the beginning of the clinical trial. But remember, this is largely claims data, EHR data, patient registry data, and so you might not have the benefit of even knowing what kind of data are in there. And then not only that, but the feasibility of doing this in a network level, so making sure that everyone has the right data points to do the kinds of research that you want. So it's a different mindset. And so it's important for you to understand this from the beginning. And I think that's a place that a lot of my students really get tripped up and intimidated. So I share this link here, and I will share it in the discussion below as well, below this video. But you really would benefit from understanding this analytic use case table, and then an application that I made that will be helpful for you that I'll show you in the next slide. So this is a kind of like Mad Libs, if you remember that, where you just say a bunch of words and then fill it in and see how it goes. Right? This is a great fill in the blank table, which you probably can't read on screen, but you can link out to it and look. But I just even want you to be familiar with this notion. It breaks the analytic use cases by type. So clinical characterization, population level effect estimation, and patient level prediction. And then it has the subtypes, and then it describes the structure and then gives you examples. And so if you can plug your research questions into these, you're in great shape for being able to lead an observational research study using the OMOP Common Data Model and the OHDSI community. And so I will leave this here and share this elsewhere, but this is just an example of how I plugged in maternal, perinatal, reproductive health examples into this because I have a number of students in that area. Just to give you a feeling, I find it easier to see examples, for folks to be able to imagine their own domain in these examples. And so I converted it to that. So you can freeze this, but I will also share this elsewhere. And so here you can go to this website. This is my personal website, boycedatascience.com, analytic use case generator. And so here I have taken those tables that I just showed you, and I have converted it into a interactive question builder. And then it also helps you to assess feasibility. And by feasibility, I don't want you to worry too much about that right now, but it has to do with the likelihood that another institution will have data like yours that will be able to help you answer your question. So if you wanted to do this, not just at your institution, but at multiple institutions. And so all of that is here. It's free. Just go to it and play around with it. And then you can download the report or copy your research question. I think it's going to be really helpful for you to have that and play around with that. It'll build your confidence to be able to do that at home. And finally, you don't do this alone. This is team science. Everyone here remembers how it felt, and everyone wants you here. We're so excited to have you here, and we want you to be a success. So you're not bothering us by reaching out. You're not behind in any way. You are exactly where you need to be. Focus on the fundamentals, learn the CDM, understand how those vocabularies work, play around with Athena, and start working on those analytic use cases in question design, and you will be great. Again, OHDSI is Observational Health Data Sciences and Informatics, and OMOP is the Observational Medical Outcomes Partnership. OMOP represents that common data model, all those tables that go into your database. Thank you. Welcome to the OHDSI community. We're so glad you're here.